Once again, we find ourselves in a lesson where these are things you should have learned in Algebra 2. I'm going to go over their basics, but briefly, because I'm expecting these review items for you. But we're going to talk about the product, quotient, and power rules for logarithms. I'll present those to you briefly. We're going to use those to condense logarithmic expressions. That means take a bunch of different logarithms and cram them all into one really complicated logarithm. We're going to expand logarithmic expressions, which is where we take one complicated logarithm and split it up into several simple logarithms. Then we're going to talk about the change of base formula, which was extremely useful back before we had calculators that could do logarithms of various bases, but it's still in our curriculum. So I'm going to show you how to do it. It may help you solving some equations by hand, although not the ones you're likely to see in our textbook this year. So the product rule, the quotient rule, and the power rule are as follows. If you have a logarithm of a product, that is, there's multiplication inside your logarithm, you can split it to be the sum of the logarithms of the two factors. So log base b of r times s is the same as log base b of r plus the log base b of s. You can use this backwards, so if you have two logarithms added together, you can combine them into one logarithm by multiplying the insides. The quotient rule is basically the same thing in reverse, while the inverse. So log base b of a quotient is the same as the difference between the logarithm of the dividend and the logarithm of the divisor. So you do log base b of the top minus log base b of the bottom. You can use this one in reverse too. If you have two logarithms subtracted, you divide them, you combine them into one logarithm where you divide them on the insides. There. The power rule is probably my favorite. If you have a logarithm with a power on the inside, you can just take that power and make it into a coefficient out front. That's an s. So you can take that power and you can move it out in front of the logarithm, which drastically reduces the complexity of any arithmetic you might have to do, because instead of taking something to like the fifth power, you just find this number and multiply it by 5. Or it could be 4. That's an s, not a 5. I'm sorry that it looks so much like a 5. So those are rules hopefully you've seen before, but I kind of explained them just now. We're going to apply them now in two ways. The first one is called condensing, which, like I said, we have two different logarithms here, and there's pieces out for coefficients out front. We're going to cram this all into one big logarithm, which is useful if you're trying to cancel the logarithm out. I mean, it makes the inside complicated. That's the price you pay. But it's easy to cancel out the logarithm once you have just one big logarithm, especially if you're solving an equation. It's just one of the ways we can rewrite logarithmic expressions. So the first thing I note is the subtraction here, which means eventually I'm going to produce a fraction with these insides. But I can't do that while there's coefficients. So I have to deal with the coefficients first, and that's where the power rule comes into play. I can take these coefficients in front of my logarithms and turn them into powers. So this becomes log base 4 of x to the 1/2 power, which, in case you have forgotten, is the square root of x. You could write x to the 1/2 power. Square root of x is probably easier to write. Here the 3 becomes a power, so this is log base 4 of x minus 2 to the 3rd power. So that's the power rule I just applied twice. Now, because I have no coefficients, I can apply the quotient rule. This is two logarithms being subtracted, so I can combine them into one logarithm. Please don't write this as a fraction of logarithms. The insides, the arguments, are what go into the fraction. You should have one logarithm when you're done condensing, not two logarithms. So the top becomes the square root of x, and the bottom is this x minus 2 cubed. And that's really all there is to condensing a logarithmic expression. If you have one that has numbers instead of variables, you may want to do some arithmetic to simplify the argument there. But in this case, there's not any simplifying to do. So this is now condensed. It's one logarithm, which hopefully you're planning to do something with. Here's our second example. This uses ln, which is logarithm with base e, but it still follows all the logarithm rules. So again, I'm going to deal with the coefficients first when I'm condensing, so that I get ln of x plus 1 to the 5th power plus ln of x to the 6th power. And then when I add these two logarithms together, I change them into one big logarithm, I have to multiply the insides, the arguments together. So x to the 6th times x plus 1 to the 5th. The order doesn't really matter, other than usually if we've got a monomial, we put it out front. So if you wrote these in the reverse order, I don't think anybody would be upset with you. So that's condensing logarithms. We should also be prepared to expand them, which means taking a logarithm and breaking it down into several simpler logarithms. This was an extremely useful thing to be able to do with logarithms of large numbers before calculators did logarithms so well. But like I said, it's still a skill that we expect, so I'm showing it to you, even though honestly I've never seen a situation myself where it wouldn't be easier to type it into a calculator when it's just numbers. With the variables, it can be useful to be able to break them down. So we want to break this down. Really what we're looking for here is prime factors. I want to break this down into logarithms of only prime numbers. Depending on your application, when these rules were the most popular, you actually couldn't do logarithms on a calculator. You had a table in the back of your book, so you just had to break them down far enough so the numbers were small enough to appear on your table. But we're not actually doing that. We're just going to break it down. So 96 is what, 6 times, well, let me build a factor tree. 96 be 15, 16, 6 times 16, which is 4 times 4. So I've got 2 times 2 times 2 times 2, and that's 2 times 3. So 96, when I break it down into its prime factors, I've got 5 2's, 1, 2, 3, 4, 5 2's, and a 3. So that means, according to the product rule, this is log of 2 to the 5th plus log of 3. And that means it's 5 times the log of 2 plus the log of 3, which if you use the table to look up the log of 2 and the log of 3, this wouldn't really be too bad. All right. More commonly for us, we're going to see logarithms with variables in it if we're trying to expand them. So I'm going to break this into its pieces. This is actually 2 multiplication steps, so I'm going to end up with 3 logarithms. ln of 4 plus the ln of m cubed plus the ln of n to the 5th power. Again, I'm going to bring this out. So ln of 4, this exponent becomes a coefficient, 3 times the ln of m, and then 5 times the ln of n. I'm not sure n was a good pick for this problem. I copied it down, but that might be a little weird, ln of n. Nevertheless, this one is now expanded. I've broken it down. Each logarithm is itself quite simple. I don't think in this sort of example anybody would expect you to break this one down, but 4 is 2 squared, which means you could end up with this as your first logarithm, 2 ln of 2. And again, I don't think anybody would complain. I'm just not sure that's something that the person who wrote this problem was expecting you to do. This right here, this one I'm expanding. It's got division on the inside, which is why it's our last example. We're going to end up with subtraction. In fact, that's the highest level division in this argument. So I'm going to do that first. Log of 2x minus 3 minus log of 3 times the 4th root of x. Now this over here is a product. This is a subtraction, a difference, so I don't have any rule for that. I have to leave this one alone. But this one has a product on the inside. But watch out, because this minus sign here, when I split this into 2 pieces, the subtraction, the minus sign here applies to both. So you can put it in parentheses, or you can just remember to negate them both. Well, this is log of 3 plus the log of the 4th root of x. I'm actually going to rewrite at this point to x to the 1/4 power, because that's what the 4th root, that's what 1/4 power means, is the 4th root. And that way, I'm prepared for my next step, where I'm going to bring that coefficient out front. Now, I don't really like these parentheses here, so I'm going to distribute this negative and drop the parentheses. I'm going to bring this 1/4 out. And there's my expanded form. I can't get this apart. There's no difference rule for the inside of logarithms. If you have two logarithms subtracted, you can combine them using the quotient rule. But if the subtraction's in the argument on the inside, there's no rule for that. So this is done. Each of these is linear or constant. It's as simple as I can make it. The last thing I need to talk about is the change of base formula. It's another one of those that was much more important when our calculators weren't quite as smart. But it basically says you can change the base of any logarithm you want as long as you're willing to make a fraction of logarithms. You can change it to any base you like. So the process here is you take the original base, it goes in the logarithm on the bottom. And you take the argument of the original one, it goes in the logarithm on top, and you can put any base you want in here for a. So if I have a problem like log base 5 of x, I can rewrite this into any base I want. So if I want to use ln, because that's one of the buttons on my calculator, I can rewrite this as the ln of x, the original argument, divided by the ln of 5, the original base. And I can do that because ln is log base e, and e is one of the any numbers that I mentioned before. I can also use log base 10, the common log, where we just write log. And if for some reason I really liked 7s, I could do log base 7 of x divided by log base 7 of 5. And if you don't believe me, stick all three of these into a calculator, you'll get the same answer every time. That's how the change of base formula works. And now I've taught it to you. I don't plan to assign very much homework that uses that. But you may find it useful someday. Hopefully you'll remember it's there, and you can look it up if you don't remember it. Good luck on your homework. Let me know if you have any questions.